Hello, so today I'm going to go over this short part, dividing radicals, and then you're going to have 6 problems that you're going to practice. And then either tomorrow or the next day, we're going to do the notes over rationalizing the denominator. I want you guys to get the feel of how to divide before we go ahead and rationalize. So starting out here, when we divide radicals, it's a lot like when we multiplied radicals. So you divide the coefficients, just like when you're multiplying radicals, you would multiply the coefficients, and then you use the quotient rule. And the quotient rule basically states that the index stays the same, and you just put whatever is left inside the radical as a over b. Excuse me. So, and you do that math and kind of simplify some things. So if we look at our first problem here, we're going to divide our coefficients first. So we need to look at 12 and 2. So what's 12 divided by 2? Well, that gives me 6. And then on the inside, I have 160 divided by 5. So now I'm going to think to myself, well, what is 160 divided by 5? So if you have a calculator laying around, you will know that you get 32 on the inside. Our last step here is to just kind of think about breaking that down and simplifying the square root of 32. So we have to think about what's a perfect square that goes into 32, and one of them is 16. That's the biggest perfect square that goes into 32. So when we do answer this, 6 still stays out front. And our final answer is going to end up being, this becomes a 4. So we have 6 times 4, and that gives us 24. And then the radical 2 stays the same. So it's a lot like the way that we multiplied things. You do the same thing for the outsides. So you divide the outsides, divide the insides, and simplify. So if I move over to this guy, I'm going to do it all in one step here now. So I'm going to do 36 divided by 9, and I'm going to get 4. And on the inside, I'll have the 4th root of 1,250 divided by 2, and that gives me 625. So again, I just did my division on the outside parts, did my division on the inside parts. So here, this one's actually a little bit more simpler than some of the other ones. Let me go to my pink color, sorry. And the reason why this is a little bit simpler is because 625 is actually a perfect 4th. So this is actually 4 times 5, which we are all smart people, and we all know that 4 times 5 is 20. So that one was a little bit simpler. We get our answer is 20 there. So when we bring our variables into these kinds of problems, a similar thing happens. So what I want us to keep in mind is that we're really doing here is the square root of x cubed y ninth over x squared y to the 5th. So when we divide variables like this, I don't know if you remember doing this, but you look at where is the bigger variable. So if we look at our y's, there's 3 x's on top, 2 x's on bottom. That means that there's going to be more x's on top than there are on bottom. So if I went ahead and cancel these out, I have 1 more x on top than I do on bottom. And then if I look at my y values, again, I have more y's on top than I do on bottom. And by how many? Well, I have 4 more on top than I do on bottom. So then I just put my square root around that guy. My last step here is to think about how many sets of 2 are in 1x, and that's none, so that x is going to stay. And then how many sets of 2 are in my y to the 4th power. And there are 2 sets of 2. So I have y squared, the square root of x as my answer for this one. So again, you look at which level has more which level has more. Is it the top or is it the bottom, depending on the variable? And then you just keep simplifying from there. So if I look at a problem like number 4 here, I'm going to simplify my numbers. So 28 divided by 4 gives me 7. And then I want to simplify my numbers on the inside. So negative 16 divided by 2 gives me negative 8. And then I need to look at my variables. So I have 6 m's on top, 1 m on bottom. That means I have 5 more m's on top than on bottom. So from here, I go ahead and I start to simplify. So this this cubic root of negative 8, that's actually a perfect cube. So I'm going to have 7 times the perfect cube, which is negative 2. And then I need to think about this cubic root of m to the 5th and how many groups of 3 are in 5. How many groups of 3 are in 5? So there are 1 group of 3 in 5. So I'll have 1 come out and I'll have 2 stay in. So this just goes back to our simplification skills when we were doing that. So what this equals, I'm going to multiply my stuff on the outside. So that's 7 times negative 2, which gives me negative 14. My m is on the outside, and I have 2 m's left inside. If I go to number 5, I have 48 divided by 16. So if I do the math on that, I'm going to end up with 3. And I'm going to ask myself, is there any more that I can do here? And no, there isn't. I can't simplify any more than that. So my answer here is actually just the square root of 3. And then I'm going to look at this guy, and I'm going to say, what is the cubic root of 40? So this one, I'm actually going to kind of break it apart a little bit to think about it, because 40 and 27, they don't have anything in common, right? So I'm going to break this apart, and I'm going to do the cubic root of 40 and the cubic root of 27, sorry. So we already know what the cubic root of 27 is, because we've done that before. This is just 3. So now I need to think about the cubic root of 40, and I need to think about how can I simplify that. So this can be broken down into 8 and 5. And the 8 is going to become a 2, and this guy's going to stay. So what I really have is 2, the cubic root of 5 over 3. The last question I'm going to ask myself is there anything else that I can do? Can I simplify anything on the outside, anything on the inside? And my answer is no. So I'm going to have 2, the cubic root of 5 over 3 as my final answer. So what makes this one different from the other ones is all of the above ones had numbers in common. So 160 and 5 had a number in common, and they divided into each other evenly. So 40 and 27 do not have anything in common. They don't divide evenly into each other, so we have to break it down a little bit more. A little bit of a similar thing is going to happen with this one. So I want to break this down into the cubic root of 7x to the 5th over the cubic root of 64y to the 6th. So 64 is actually a perfect cube. So this becomes 4. And then if I look at my y's there, how many groups of 3 can I make out of 6? And my answer is 2. So on the bottom, I have 4y squared. And now on the top, there's nothing I can do with the number. So I can change my number so that cubic root of 7 is still going to stay. But then I can look at my variable and think, how many groups of 3 can I put in 5? And my answer is just 1. And I'm going to have 2 left over. The last thing I'm going to do is ask myself if there's any more simplification I can do, which there's not. So my final answer here is going to be x, the cubic root of 7x squared over 4y squared. This is the last one, and then I'm going to give you guys your assignment for the day. So for this one, again, 32 and 81 do not divide evenly into each other. So I'm going to break these guys up into the 4th root of 32w over the 4th root of 81. And again, these guys, 81 is actually a perfect fourth. So this is just 3. And then I need to break down my fourth root of 32w on the top. So when I do that, the perfect fourth that goes into 32 is 16. So the fourth root of 16 and the fourth root of 2. And this is, anybody know? It's 2. So I have 2, the fourth root of 2. But I can't forget about that w, which needs to stay inside because there's not 4 of them to come out. So my final answer for this one is going to be 2, the fourth root of 2w all over 3, because there's nothing more that I can simplify there. 2 and 3 don't go into each other. I can't do anything else with that 2w, so I'm going to keep that. So I just gave you 8 examples on how to do problems like this. And then you will have 6 problems to do for your assignment today. So I'm going to highlight those for you. So it's going to be number 1, number 2, number 3, number 4, number 5, and number 6. We will move on to the bottom, not today, or not tomorrow, but maybe the next day. I just have to see how well you guys do with this before I decide what we're going to do about rationalizing. So